determine if the series n equals 1 to infinity, square root of n plus 4 over n squared converges or diverges. So let's say you were given this problem. What could you try to do? Try the divergence test. Okay, let's do that. Like I said, you can always use it. It's not always helpful, but we can at least always use it. Apply it. What's the limit of this going to be? Infinity over infinity. Okay, so you maybe want to use the L'Hopital's rule, is what you're telling me?
It just gets nasty though, when you get like a 1 over 2 squared.
It will, but, so there are two ways you can go about this, right? You could change it into x and do L'Hopital's rule, and it will, the numerator will look messy, yes, I'll give you that. But the one nice thing is when you take the derivative of the top, the 4 goes away. The plus 4 in the numerator, what that means is you're going to be able to simplify whatever's there. Okay, so if you wanted to do L'Hopital's rule, you insert in an x, and then when you go to use L'Hopital's rule, you're going to get 1/2 x to the negative 1/2 over 2x So if you simplify that, you'll get 1 over 4 x to the 3/2 in the denominator. And now what is that limit? 0.
All for not in any way.
Yeah, I mean, like I said, if you have no idea, where to start with that divergence test. I mean, if you get something that's not 0, so if you got 1 for this limit, you would be done. It's no harm, no foul. You tried something, it didn't work. So now you gotta try something else, right? Just like with the integrals, sometimes you try something, it doesn't work. Okay. So we could integrate this if we wanted, right? But that's actually going to be really messy. It's going to be worse than this L'Hopital's rule because of the square root of n in the numerator. So instead, could I try to simplify those terms here in my series? How could I simplify that?
Since you have a single numerator or denominator, can you split it up?
Yeah, you can split it up. Let's do that. Okay. So let me go back to my series here. I have a single denominator, so I can split this up. And then for the first term, I could simplify that. What would my power be? 1 over n. 2 minus 1/2. 3/2. So I really got these two pieces going on here. Look at the first one. What kind of series is that? It's a p-series, right? The second one, what type of series is that? It's also a p-series. So all I gotta do is look at each individual p-series and see what happens, right? So let's look at the first one. 1 over n to the 3/2. We said this is a p series. What's my value of p? 3/2. So does it converge or diverge? Converges. Anytime p is greater than 1, it converges. Let's look at our second one. There's this 4, but I can pull that out, remember? 4, I can pull out the constant. 1 over n squared. You told me that this is a p series. What's my p value? 2. Does it converge or diverge? Converges.
What if one of those were less than 1?
Then the whole thing would diverge.
So you can get like
You need what?
so like even if you had like one convergent but the other one wasn't divergent, it's
Yeah.
still divergent.
Yeah, they both have to converge in order for the whole thing to converge, yeah.
So the P series can essentially prove both ways, right? Both the convergent and divergent?
Yeah, a p series, as long as you know your value of p, you know if it converges or diverges, so you don't have to do any test. That's why we were able to avoid doing the integral test here, is because I simplified the terms and I recognized, hey, this first thing is a p series, this second thing is a p series, and I know how p series work. I know the whole story, and so I don't need to do anything else. Okay? Okay, so then this tells me, because these things converge, that my original one, so this one, which was square root of n plus 4 over n squared, also converges.